Assalamu alaikum everyone. So in this video we are focusing on the problem on lab 1 question 5, which is known as finding all the corners. It is also known as corners problem. So here is our goal is to find the shortest path that goes through all four corners of the maze. Now it is not important that all four corners should contain a foot dot or not. Our concern is only that we find the shortest path, so we will focus on that. And we already have a hint that the shortest path for tiny corners takes 28 steps, so we will look into this type of results. And so let's go into the code. So to solve this problem, we will need to open the search agents.py file, and now if you scroll, you will find the class called corners problem, which contains the parameter search problem. It is a separate class to access the functions. So here we will need to implement these four functions. That is get start state, which will return the starting state of the pacman. Is goal state, which checks the current state is our goal or not. Get successors will return the successor nodes of our path, and get cost of action is whichever action we take, what kind of cost will it incur. So let's go into the implementation. So for get start state, it's very simple. We will need to return the starting position and the corners that we will use. So serve the starting position and serve dot corners. If you look that we will already have initiated some variables in the constructor, and there are walls, there is starting position of the pacman, which we get through the get pacman position function already defined, and there are corners. We calculate the corners, and we store the corners in a set with 4 tuples. So this gives us the corner states, and we are just returning the starting position variable and the corners set. Now in the goal state function, we need to define a corner list. So this corner list will contain all the corners that we have. Now here state 1 actually returns this set that we already have defined before. This set is stored in the so this state 1 actually stores the set on the corner list variable. What we will do, actually we will take all the corners in this corner list variable, and then we will check if we have visited that corner. If we have visited that corner, then we will remove that corner from our list, and if we don't, then it will remain. Until we read off all the 4 corners, the corner list will become empty, and we can see that we have reached our goal state. We have visited all the corners. So that is our goal, and that is the main idea of the solution. So for corner in corner list, so we are traversing through the corner list, and if corner then return false, because we haven't we already have entries in the corner list, so we haven't visited all the corners yet, so we return false. And else we will return true, because we have visited all the corners. So that's the implementation of is goal state. Now in get successors function, we have already have a successors list, and we have 4 actions, that is north, south, east, and west. So we will use it in the later part of our code. So let's begin. So we will first need a coordinate, the coordinate of our pacman. So state 0, this returns the current coordinate of our pacman. Then we will use the corner list, which contains all the corners. So list state 1. So as this is defined earlier, that these corners are in a set which is immutable to done this. If you know about the Python data structures, there are basically 4 kinds of data structures. There are set, there are list, there are dictionaries, and there are tuples. So in case of set, it is immutable, that you cannot actually modify this after define. So in order to do some operations, we need to convert it on list, which is a mutable data structure. So where were we? Yeah, here list we have converted, and then we have stored it on corner list variable. Then we will need to define our action, that is dx and dy, and actions direction to vector. So what this function does is actually it converts the actions into something that is calculatable. So we could do some mathematical operations on it, and these north, south, east, and west is converts into some mathematical terms. We need to focus on that for now. Okay, and then we need to know the next coordinates that we will go. So next x and next y contains that. Remove the space from here. We need to convert it on integer. Okay, so con x plus dy. So our previous coordinates plus our direction that we have converted. Integer y plus dy. Now we need to check if this next position is a wall or not. So okay, if not, self dot walls self dot walls, and then we pass the coordinates next x and next y. So we are checking if this coordinate is not a wall, then for I in range, so there is the 4 directions, 0 to 4. If next x and so what we have trying to do here is actually we are checking that if it is contained in the corner list list. So corner list contains all the corner coordinates. If you have seen here, yeah, here. So we have stored all the corners here, and we have contained in a list. So it converted in a list, and then we stored it here. So what we are checking, that we are passing these coordinates, and then we are checking if these coordinates are in the corner list. So if it is in the list, then it is a corner, of course. Then we will just pop it. So to do this, we will just make this none. So this will just remove it from the list. And if it is not, what we will do, we will this part is a bit tricky. We will successors, and then we will consider the next move. So we will pass a list. Inside that list there will be a set, and that set will contain a tuple with the next position coordinates, next x and next y. Then tuple, we are converting it to tuple again, the corner list, because we have previously converted to list for doing some calculations. Now we are passing it again as a tuple, and then we will pass action, that is the action we're taking to go to that next position, and cost is 1, because the question, if you look at the question, so yeah, when coding up get successors, make sure to add children to your successor list with a cost of 1. So we are doing just that. So now we are just return the success. So that is already implemented. We return the successors. So it's done here, and now we have to implement yeah, so that is done here, and the get cost of actions is already implemented here. So what happened here is actually if the action that we are taking is an invalid action, we will just return a very large number, and if it is a valid action, then we will convert that action something that we can calculate. So direction to vector function, and then we just take the coordinates, and if there is a val, then it is a invalid action, so we return a big number. And finally, if it is a valid action, then we will return the length of the actions list. So that is basically, this is the number of actions, how many actions have you taken to how many steps have you taken to traverse all the corners. So if you remember, if you do it correctly, then it will return something around 28 steps. So that is all for the implementation of question 5. Thank you.